Welcome. Thanks so much for coming. I'm Kevin Burnett, and this is how we do DevOps at Rosetta Stone. Here's the plan. I'll provide a bit of background, tell some war stories, describe our tactics, and then highlight a few of the themes that have been relevant for us and that I hope can be helpful for you. I think you've noticed, and as was brought out in the keynotes, technology evolves quickly these days. And that, I assert, is because of people just like you. If that's not obvious, consider we're hanging out with the person who created the most popular CI/CD tool in the world and the guy who introduced continuous delivery to much of the world. And these are folks who think substantially the way you do. There are a lot of very hard problems in the world, and I believe that technologists like you and me can change the world. And I think this is becoming more true each day. Not too long ago, it was very common for folks to release software only like every week, or maybe even once a year. And now, we release software multiple times a day. And with so many more opportunities to make changes, it impacts the way we work. It's much easier to stay in sync with our customers, to keep our code bases clean and nimble. And this empowers our people. It turns out that technologists care a lot about how they do their work and about how well the software pipeline functions. And so if you can have a positive impact on the way they do their jobs, it will matter to them, and that means a lot. So this is the backdrop of my talk and why I've really enjoyed working on DevOps and process improvement work. It makes a difference, DevOps does, for those of us who do it and for the folks that we worked with. I started working at a software company called Rosetta Stone in 2004. We make educational software. Our mission is to change people's lives through the power of language and literacy education. So I feel fortunate to have work that's not only a pile of fun in my function, but where we're also all contributing to something worthwhile. For a bit more than 2 years, I've been focusing on DevOps. And there's just two of us that only do DevOps. That's me and my teammate, Jason, who I'm really happy to get to work with. He's awesome. We're part of the product team, and we happen to come from the dev rather than the ops side of the house. The product team is quite geographically distributed, but the two of us are in the same office and actually on the same floor as the ops team. And that's a group that's very capable and also very sympathetic towards what we're trying to do. We don't have a product owner, apart from the two of us. We do keep track of most things that we work on by filing tickets for ourselves in Jira. And especially for the folks who depend on our tools, we try to always be available within minutes, because keeping people unblocked is very important to us. So at a high level, we've made some cultural and people-related changes as well as some technical changes. So we've implemented continuous delivery, moved a pile of apps to Docker-based builds and deployments, help make our test environments a bit more sane, and we've moved everything over to Jenkins. And of course, with that, everything just fell into place as if by magic. You know how it goes. Some of the standard DevOps metrics indicate that the effort has been working out relatively well. We're releasing more, and our releases tend to go a lot better. And check it out. I'll give you a new metric in case you want to start measuring it. If you put all of the automated acceptance tests at your company into one gigantic suite, and you run that thing, how often does it pass? We didn't know either. We started doing it. We found out that the answer was basically never. But now we can claim that the answer has changed to sometimes. So it turns out moving in this direction is really important, because it doesn't matter how fast or how exhaustive your automated test suite is if it doesn't run reliably. But even more important than DevOps metrics, if that's possible, our stakeholders are seeing an impact. So one of my favorite pieces of feedback came from a product owner, indicating that continuous delivery was one of the necessary factors that allowed us to meet our business commitments. I'll touch on the hardest people-related issues that we encountered along the way. Change is hard, right, in general, but some change is really hard. And so I'll hit continuous delivery first. We'd wanted to release software more frequently for some time. We believed the hype. We had knocked down some of the prerequisites. We had automated our deployments. And so we started asking around to see if we could change our processes. So one obstacle to overcome, when you already have a decent process in place, your colleagues might be a bit more resistant to change. So we had set up a very strong released cadence, every 2 weeks, like clockwork. And many folks remembered what it had been like before we had sort of instituted this process. And so they knew how relatively good things were. And it's natural for folks to wonder, with any big change, how is this going to screw up the good thing that we have going? So this is the danger of good enough, and how it can lull you into complacency. So given that status quo, we wanted to communicate to our colleagues that there was another way. So for the developers in the house, and who here might self-identify as a developer? Excellent, comrades. You intuitively understand that small changes are safer. When you're coding along, you don't code for 2 weeks and then stop and compile or run unit tests, right? You start with a working state, you make a small change, and you make sure that things still work. In this way, if something does go wrong, it's easy to determine the cause, that thing you just typed a minute ago. Funny to discover why something is broken, not always the most fun part of our jobs. So we try to avoid big changes, and it worked the same way with software releases. So with our previous process, there would be 2 weeks of dev work, 2 weeks of QA, and so the cycle time was somewhere between 2 and 4 weeks. This implied a big bang deployment of all of the things that had been developed during that cycle. And this turned deployment day into sort of a large event. And having deployments be an event is not what you're after. So there were meetings, lots of approvals, and people pulling the trigger to deploy who were not ultimately very close to the code being modified. A web of microservices is already a complex system, but when you change essentially all parts of it at the same time, it can be very difficult to anticipate the impact the changes might have. So even with lots of testing and all the process we had put in place to prevent failure, things would still fail. We'd miss things and surprises would crop up in production. And then, to add insult to injury, when things did go wrong, rollback was typically not an option. This is because we're rolling everything as an atomic unit. And so in order to go back, everything had to go back. That would include features, bug fixes from many teams, and that many stakeholders were expecting, if not depending upon, to be there at a certain time. And so we learned that the larger the change, the more intractable rollback actually became. So there are some good arguments for continuous delivery investments, but it ultimately comes down to people and trust. We were very fortunate to get the opportunity to meet face-to-face with some of the folks involved on the product team regularly. We use a process framework called SAFe, the Scaled Agile Framework. And it encourages a ceremony called Program Increment Planning. So these are essentially quarterly planning meetings, but they're a bit unconventional. They're always face-to-face, and they have a lot of unstructured time, which is actually perfect if you're looking to foment a revolution. So at these meetings, one of my favorite pastimes was to just name audacious goals and request everyone's help to try to meet them. And then we would just talk to as many people as we could to get them excited about our future plans, to find early adopters and advocates, and to adapt our plans based on the feedback that folks were always very willing to offer. So when we were advocating for continuous delivery in discussions like these, what it came down to, oftentimes, was how many prerequisites folks felt needed to be met before we would make this big change. So if you're conservative enough about the level of testing required or about your tolerance for production failures, it can start to feel a lot like an argument for the status quo. And often with changes like these, the margin between success and failure is small. We tried to impress upon people. We're not ever going to have complete test coverage, even if all of our test suites say 100%. We won't eliminate production failures, they'll always be there. And if we wait to change until conditions are perfect, we'll be waiting a really long time. So all this talking led to a small, very successful continuous delivery pilot, more talking, and ultimately a measured rollout from team to team of this process. And at the end of the day, most of the company is doing continuous delivery. So we're now releasing multiple times a day, and each change is small and low risk. continuous delivery has been seen as a success almost universally by our stakeholders. So change is not easy. Have patience, keep pushing, and it will come. We followed up the continuous delivery process change with another big request to change. So we wanted to provide a way to run all of our acceptance tests on any environment. In order to do this, we had to reduce our reliance on long-lived, organically grown test data. And the QA guys and gals, visualized here as a dinosaur with sharp teeth, are like, hey, did I hear you were thinking about deleting our test data? And you're like, maybe. But after we get it in version control, then everything will be great, and all of your data will always be available on any environment. And then your QA people might be like ours and eventually say, all right, sounds good. How can we help? Or they may eat your face. Your mileage may vary. But the point is, you're going to spend a lot of time with your test data, regardless of how you decide to deal with it. What we had observed was that QA folks were debugging failed acceptance tests a lot. And oftentimes, the problem was data related. They'd pass on QA1, but fail on the QA2 environment, for example. So instead of maintaining these environments through ad hoc and brute force methods, we went about getting our test data in version control. So now we have a script that can refresh any environment and put good known data in place. And so the same way Netflix can deep six problem servers and replace them at will, we never have to worry about busted data on test environments. We can just blast an environment, install fresh data whenever we want. And we do this hundreds of times a day, mostly driven by our pipelines. So while we iterated towards this test data corpus, we needed a way to ensure that we were adding the right data and not removing anything we needed. Well, the great thing about codifying test data, you can know with certainty that you've done the right thing, at least in as much as your automated tests are concerned. So we pulled together a meta acceptance test suite. That is, we essentially ran all of the acceptance tests at the company. And that's it. You just need to run your tests after you install your test data. If they fail, you have more work to do. So you fix your data population script and try again. And so in some sense, this is easy, right? But it takes a decent amount of time, as you can imagine. And it took, at least in our case, contributions from folks with expertise in the tests and in the systems under test. And rallying a lot of people to do pretty much anything is hard. And if you're deeply invested in the cause, the way we were, with continuous delivery and with codifying test data, it can feel like an epic struggle where you can someday maybe succeed. It can be fun when you're having lively debates, learning from and inspiring others, and forming a coalition, the way William Wallace did in Braveheart. But it's only at the end of the struggle where it comes to a head, where it really matters, and where you may or may not be dead, but Scotland is free, or you have more frequent releases, or whatever the case may be. This is how we've experienced organizational change, the hard stuff. Another way to create value is to improve the details of how you work. So if you would, put your hands up if you have used Jenkins files. Super. And your hands up again, if you could, if you've used declarative Jenkins files. Okay, excellent. You can put your hands down. So you all know that you can validate declarative Jenkins files, right? This is one of the sweetest pipeline features. You can go ahead and take the contents of your Jenkins file, post it to the Jenkins API, and it will tell you if it's good or not. And so we hooked this into Vim. All ops and DevOps people use Vim, right? So you can now hammer a keyboard shortcut, and it reports in context in your editor whether or not your Jenkins file has correct syntax. So you can go check it out on GitHub if you like and configure it to work with your Jenkins setup. The next best thing after Vim is, of course, the command line. So we share a number of functions across our company in a .files repo. And things like last build result, where we can see that the build was successful, farm this work off to Jenkins. The next example that I want to show here is one of my favorites, because oftentimes before I start work on an application to go make any change, is that I'm going to go ahead and make sure the pipeline is clear. That is, there are no unreleased changes on master. And so I can know that the release will only include my changes. If someone else's changes are also in the release, it adds confusion. And I might try to blame that person if something goes wrong. And that's not efficient, right? Because the problem is definitely my fault. We use Bitbucket Server to host our source code. And you can organize your repos there by project. We do that, and we use the Bitbucket branch source Jenkins plugin to make sure that we mimic that source control structure exactly over in Jenkins. And in this way, if we follow these conventions, it's relatively easy to get visibility into, for example, all repos in a project. Automated software maintenance is one of the things we get into that isn't discussed a huge amount, especially in the context of DevOps. So the big idea is you essentially have a change, and you want to apply it to a number of apps. So you could make that change in your editor by brute force, by going in, mashing your keyboard, manually typing code and configuration. We try not to do that, and instead spend time codifying that change in a script up front. So once the script works, you don't need to worry about careless mistakes when you're applying it, time-consuming updates, etc. So in case you're wondering, why are you making changes that need to be applied in a number of apps in the first place? Are you copying and pasting a bunch of code here? What's going on? So this practice by no means diminishes the importance of sharing code in libraries. In fact, one of the very first use cases we had for these auto-maintained scripts was to keep library versions up to date in each app. So certainly the best way to keep apps in sync is by sharing code, and auto-maintenance scripts can help for changes around the periphery of your applications. Automating your software maintenance solves several problems. It can help mitigate unnecessary divergence in a microservices architecture. It can help prevent your build plans from getting stale. And most importantly, it lets us humans be lazy, so we can spend more of our time on really hard problems, like trying to figure out why JavaScript is so popular. So microservices can be beneficial as you scale, since each of your teams can move independently and have code bases that are easier to understand and maintain. But you don't want your microservices to diverge unnecessarily and in ways that make your organization slower. So people will change teams, people will join the company, and certain standardizations can make these transitions easier. So write scripts to update your apps so they stay similar when it's beneficial to do so. Automated software maintenance can also help you fight stale builds. So what do I mean by a stale build? You know that thing that happens when you go ahead and make a change in an application, seemingly innocuous, the build breaks. You go into Jenkins, you find that the only change is yours. I guess that's good and bad, because theoretically I should be able to just remove that change, right? And everything should be fine. So you do that, let's say. You go ahead into source control, you revert your change, builds again. It's going to be great. It's not great. So things can change in the environment, as it turns out. It might not be your change that caused the issue. And the longer it takes to detect these sorts of brokenisms, the harder they are to fix. The solution is to build more frequently. So use automation to reduce the impact of the passage of time. This is how our auto-maintained script is executed. So you go into the repo that you want to update, fire off a command line script. And so we implement it with a Z shell function in our .files repo that in turn runs Ruby scripts, it hits APIs, it does all kinds of crazy stuff. I'll give a couple examples of the sorts of things that it updates. So the first is to make sure that we're running the newest version of the Docker base image in the app that we're updating. So one of the ways that we share configuration for similar apps is by creating these Docker base images, so we can have each application use that common configuration. When the base image is updated, there's no reason to leave any apps behind. They should all use that new version as soon as practical. So maybe someone updated the base image to add the Vim package to a minimalist Docker container, right? Docker image. So we want to make sure that we have Vim available even in Docker containers, because Vim is awesome. Of course, they're absolutely correct in doing this. So when you made this change, the base image build plan would run in Jenkins, push a new version to the Docker registry. It's master 13 in this case. And then, when you run auto-maintain in all of the apps that use this, it will notice that there's actually a new version of your base image, update your Docker file to reference it, and you're on your way. Here's a second use case. Maybe you decide it's probably good practice to archive old Jenkins builds. So you come up with a policy, maybe that everyone can agree with. Maybe you decide to keep only 100 old builds in each project. So AutoMaintain implements this policy by adjusting the Jenkins file accordingly. So in this case, the AutoMaintain script is implemented by checking to see whether the term build discarder shows up in the Jenkins file. If it doesn't, the script adds or updates an options block after the agent block. That's what I wanted to cover on automated maintenance. Any questions here? Yes? How are you parsing that file? Oh, nothing that fancy. Man, we want to write this script in less than 10 minutes for each individual task. So sed, awk, Perl, all of your favorites. And you could definitely go into, get more involved if you had like a more complex task, and you can weigh the options of whether it's worth it to do that. So I've mentioned that we try to deploy small changes frequently. I've talked a bit about our development workflows, and now I'll cover the build and deployment flow, our Jenkins pipeline and testing, chatbots, and logging. And after that, if I've missed your favorite area, feel free to ask. So these are some of the tools we use to try to make shipping software less terrible. So we've been on Jenkins since the Hudson days. Don't tell Kosuke, but we've been a bit unfaithful during that time. At some point, maybe we moved 80% or so of our CI workload to another fancy CI server. It's only recently with the awesome pipelines features that we moved everything back, and we couldn't be much happier. So this is a real live deployment pipeline as visualized in our favorite CI/CD tool. So this set of stages is used for many of our applications. So it starts with a commit stage where we run our unit tests. And then we do some static analysis to mitigate potential security issues. And then it keeps getting slower and more thorough as we move to the right. So there's data refresh where we claim an environment so no one else can use it. We go ahead and deploy the application under test out to that environment. Then we run all of our acceptance tests. And if the pipeline doesn't stop us, we roll out to production. And then we just clean up. We deploy that new release to all environments. And we push the code change that was made, that just made a master out to all of the feature branches. So one of the key aspects of our deployment pipeline is the way we think about what tests to run. And we've set things up so that by default, we pretty much run everything when we change anything. And this doesn't include the unit tests of unrelated projects, for example, but we try to run all acceptance tests whenever we change any microservice. So this is the safest option, right? We're not going to miss any tests. And we leverage Jenkins parallel steps to make this feasible and keep the testing time reasonable. And a shout out to Jez Humble, who's in the house at Jenkins World this year. In the spirit of, if it hurts, do it more often. Blocking all apps on the results of running acceptance tests in all apps will definitely help you figure out what tests fail frequently so you can get to work fixing them, and so you don't kick the can down the road. So what about deployments? Jenkins is not necessarily a deployment tool. The most common flow, which includes non-prod and prod deployments, is handled by the pipeline. But what if I want to deploy an arbitrary version of something to some arbitrary environment? To handle this use case, we dump all data about builds and deployments to an internal tool via an API. And that is the internal tool that presents our deployment UI for arbitrary deployments. The UI is very simple. You just pick a build, pick a target environment, hammer submit, and it goes. And so the way it's backed up is by a Jenkins job. And that Jenkins job takes two parameters, essentially, the build tag and the environment, and it's the thing that does all of the work. Does this make some sense? Is this how everyone does deployments? Cool. So we use chatbots to make the scripts we run less secretive. We do share a .files repo, so it's available to everyone. It's not actually a well-kept secret. But there's nothing quite like executing commands out in the open in a public chat room to sort of show everyone how things are done around here. And this deployment function is just one example. We do use some off-the-shelf chatbot plugins, but most of the interesting functions we've written ourselves in Ruby. What about logging? So there's a document on the internet called the 12-Factor Manifesto. It's basically some guidelines that the folks behind Heroku put together and wrote down that talk about how to build apps in the one true way. So they say, thou shalt log to standard out and let the log stream be the sort of purview of your logging infrastructure. So this is really simple from the app's perspective, so makes it fairly compelling. Docker loves it, so this doesn't hurt. And so we tried this for some amount of time. We ultimately settled on logging to files, since Splunk loves files. And of course, we don't ever have stack traces in our logs. But if we did, hypothetically, each full stack trace would show up as one event, kind of like you want in Splunk, if we let it do its automatic parsing of our log files. Now, if you could think back for a moment, have you ever had something break in production? Maybe you had indications about when it broke. And it would have been nice to have a place where you could go to discover all the things that might have broken it. So we wanted this for some amount of time, and now we use Splunk as our company-wide changelog to solve this problem. So the thing that makes it useful is that it includes everything. So it includes app changes, configuration management changes that we happen to implement in Chef, and just ad hoc changes that we might be making that maybe a developer requested or that something needed to change in production. Using a tool like Splunk for this is nice because it's easy to ingest changes from many different sources. And it's also easy to get information out of it, because sometimes it's nice to be able to refine a search when you're looking for that terrible change that broke everything. The way that we've implemented DevOps has not resulted in bankruptcy of the business. It hasn't caused subgroups in the organization to engage in physical violence of any kind. And so perhaps it's generally working, right? So I'll try to bring out some of the reasons I think we've had some limited success in the hopes that some of these things might be valuable in your context. You've heard about the goodness of autonomy, mastery, and purpose, right? Confirmed. Autonomy is wonderful. I don't know how common it is for people doing DevOps work to be both defining and sort of executing on a vision. But this has had a super positive impact on our work lives. A simple call to action here is, if you're directly or indirectly managing a DevOps team, or possibly any team, here's your chance to really make a difference. Let your people generate their own requirements. And I can't overstate this one. If you're doing this type of work, you must find allies. Change efforts like DevOps transformations can fail for myriad reasons: lack of resistance, lack of energy, and so on. All of these obstacles are best overcome with lots of support. So a tried and true approach to organizational change is to start with sympathetic people and groups first. We've definitely benefited from this, as many sort of early adopters have become huge advocates of new ways of working. They've helped to show others how to navigate the changes and gain the most benefit from them. So we're always trying to grow the DevOps group without actually growing the DevOps group. And since we volunteer ourselves to be ops people, devs, and QA folks at different times, people in these roles have been receptive when we've tried to recruit them into our initiatives. A prime example from our experience. You know who you want on your side? QA. We found that QA folks were willing and able to contribute enormously. They've done a huge amount of the hard organizational change work, from implementing and scaling continuous delivery to codifying test data and improving deployment pipelines. Really nothing of any consequence would have happened without their support. I strongly suspect you could think of people in your organization who could do greater things if they had the opportunity to spend their time in a different way. Sometimes, when people have so much to do, they can feel like they don't have time to improve the way they do things. This is a self-perpetuating behavior, however, and ultimately, it's a prioritization problem. Agile and Scrum can actually be used in ways that prevent process improvements. Tech debt and process improvements can take a lot of time. And so when a team gets into a sprint planning session, for example, these big ticket items can feel like they're not quite the right thing to do just now. And then that sort of deprioritization can happen every sprint. So one way we sidestep this problem with DevOps is by moving the typical feature queue out of the way and letting the DevOps group prioritize their own work. Quoting from the DevOps handbook, this is one way we value improvement of our daily work more than the daily work itself. While some of the hard cultural change initiatives were ongoing, and when lots of other people were hoping to shoulder this load, we were able to work on things like modernizing and Dockerizing our applications, creating a one deployment script to rule them all so we could get these applications deployed with zero downtime, and then just sort of writing glue code to codify our desired processes as these have evolved over time. And a funny thing happens when you start changing your processes, even in small ways. People will want to change them again. So for example, people request things like, could our tickets be closed automatically when we release something to production? Could we be notified when someone releases this app to a certain environment? Could we get a list of the flakiest tests? And the answers, of course, are, sure, probably, it's just code, right? So we come from development backgrounds. So we know the value of automated tests. So the type of code we work on, deployment scripts and glue code, they're not the first thing that's always automated. But as someone who cares about your deployment pipeline, you had better hope that everyone is writing automated tests. And so if you're not, you'll end up sad and lonely and with broken deployment scripts. So write tests. Ultimately, the thing to remember is that most of your processes can be improved. It's very safe to assume for most processes and practices, there are organizations out there doing them way better than we are. And so if you can get over the fact that this is a little depressing, it's actually one of the reasons DevOps is so much fun. There are so many opportunities to improve. DevOps practices can turn companies around. Unfortunately, they don't guarantee success. Your competitors will be more than happy to eat your lunch regardless of what you do. But looking at your processes, finding bottlenecks, and improving them is, in my experience, likely to be a very enjoyable and productive use of your time. DevOps, to me, is evolving technical processes until they're indistinguishable from the best technical processes out there. If you're going to do something, do it to the fullest. We're all here at Jenkins World not because Kosuke made a CI tool. That's been done before. It's because he made it awesome. And we're also here today because he didn't let Jenkins become irrelevant in the face of serious competition. He and the community decided to reinvent it. So thank you so much for coming. If you can please log into the mobile app and leave some feedback, I'd love to hear what you thought. I love how DevOps and continuous delivery have impacted our company. I hope that your time at Jenkins World motivates you to go spread awesomeness throughout your area of influence. At this point, I can take questions. Thank you. You might have to say it a little louder.
Do you release all 3 branches or from the mainline?
From mainline. So it's sort of a modified Git flow, which is actually simpler than Git flow. So there's 2 types of branches. There's mainline and then there's feature branches. So we fork off temporarily for a feature branch, file a pull request, and it gets back into mainline, and then there's fancy stuff that happens on mainline that doesn't happen anywhere else, like deploying to production, for example. Yes, sir.
You mentioned you do static analysis, right, for security checking. So what tool do you use?
Yeah. There's a Ruby-specific tool that we use for many of our apps. I'll have to remember the name of it. I'll get back with you.
Brakeman?
Yes, thank you, sir.
What was it?
That's Brakeman.
And when you run all these tests, whether it's QA or security tests, and you find some issues, what do? You break the pattern and create Jira tickets, and they are supposed to fix all the issues, or you say, okay, I accept the risk, and then you can go to the next phase. How do you handle that?
Yeah. So the question was, what happens when something breaks? What's the next step? So it depends, I guess. So if it fails at unit test stage, at commit stage, that's definitely a sort of developer issue. They need to go and fix their unit test or fix the code that actually broke something legitimately. If it fails at acceptance test stage, we have QA folks mostly maintaining those tests, and so we have to sort of decide whether it is sort of acceptable if we happen to know that it's a flaky test, we might sometimes release to production anyway. But generally, we try to get those things hammered out, and so it doesn't happen in the future. And so we wait until we get a clean build so we can be more confident that we can release to production. We also can't get all of the fancy things that happen on master unless we have an actual clean build. So that's another sort of incentive to make sure that we actually get a clean pipeline, all green.
So do you have the same pipeline for all kinds of releases? Maybe it's a release candidate, maybe it's a major release, a minor release. Do you use the same pipeline, or you deviate from the pipeline saying, okay, this is a small change in the JavaScript, I don't need to run breakthrough because it takes maybe 4 hours. Do you have that option, or it's the same pipeline for every single change?
Yeah. So the question was, do you have different pipelines for different use cases, small changes, tiny JavaScript changes, massive architectural changes? So we try to make it so that most changes are small changes. So the answer is mostly no. We always use the same pipeline. So and in reference to the 4-hour sort of stages, we actually don't have any of those. So they're all equally painful. They're all around 20 or 30 minutes. And so we're always trying to improve that sort of duration so we can make everyone's lives easier. But yeah, so we mostly have that one sort of standard pipeline that most apps use. Occasionally we'll get a request to be able to skip tests if, like, it's mostly hypothetical. People bring up the use case. What if there's a production issue and we determine that it's so broken, we would rather get a change into production without tests faster rather than waiting to have more confidence with the pipeline. So we've never actually had a case like that, but we do have the ability to skip tests if there would be a situation like that. Yes, sir.
My devs would all rather have their own Git repository. As DevOps, I find a lot of repositories to be really clunky and really adds in conventions, right? Solutions based. How do you arrange? Do you have any rules for, like one repository per microservice or something like that? Do you have any rules of thumb for that?
So how many repositories? The person mentions that it's easier to have fewer repositories. As a DevOps person, devs love many repositories. So we have many repositories. So we've talked about going the complete opposite direction, going monorepo, the way the cool kids do sometimes these days at Google and Facebook. And a lot of people at Google and Facebook hate it, I think, but there's a lot of benefits to it. So that's something that we're sort of thinking about. It's a huge change if we were to do it. But yes, in general, we have many repos, so we do what the microservices folks talk about.
So one for microservices is kind of the way you're doing it now.
Absolutely, yes. Yes, sir.
Just had a quick question, like you were talking about tests. I guess one thing I'm kind of struggling right now is like, how do you incentivize your devs to kind of spend the upfront time on unit tests and like integration tests, I guess? Because right now it kind of feels like, they are incentivized to just be pushing the features out and not necessarily spending time on the testing. So then that burden falls on the QA team. And typically when they're doing the tests, it's more end-to-end, with the Selenium or the web browser stuff, and that usually leads to more headaches down the road. Do you have any like tips or suggestions for kind of dealing with that?
Amen on that.
How do you incentivize developers to write unit tests? That's tough. It depends a lot on people, in my experience. There are some developers, I don't know, like sometimes you get senior developers that come in like that have worked at companies where unit testing has been important, and those guys are huge forces of influence to like make sure folks understand the benefit. There's like when you operate in an environment where there are good unit tests, it's so like it lifts a huge burden off of the developers, and so it's something that often needs to be sort of gained through experience, really. And so if you can get someone to sort of advocate that sort of mindset, can be really helpful. Yeah. Yes, sir.
So how do you handle the compliancy, change approval, CAB and all while you are meeting your speed? What techniques or processes did you get used?
So, yeah, so I guess I'll say what sometimes DevOps folks say is that all of these sort of things that we do, like putting our pipelines as code, and running tests and running security tests and having that be automated instead of there being manual sign-offs, all these things support compliance efforts. And so the more we elevate our practices with automation, the more we are able to be compliant and the more that we can show traceability. So that's sort of the angle of attack that we've had. Yes, sir.
If frequent builds, how far do you let your pipelines run? Do you let them run end to end?
They do all of the painful stuff. So they run as far as acceptance tests and as far as like claiming actual environments and doing all the slow stuff. So it's the only thing that they don't do is deploy to prod.
Okay. Deploy to staging or deploy to another
Yeah.
pod?
Yeah, all of our non-prod environments look like non-prod environments, generic vanilla non-prod environments. So they're all sort of the same.
Okay, but they're similar to your production environment.
Correct.
Okay, thank you.
Yes, ma'am.
Do you use anything to keep track of your test results and be able to easily figure out what failed to do?
Yes. How do you keep track of your test results? We do use Jenkins for that. We do actually dump those results out into our funny internal tool as well. That's where we get our top 10 list of the most terrible tests that we should be ashamed of.
So you built an internal tool. Is it like a database or?
Yeah, it's basically a simple web app with a MySQL database. Yes. Yes, sir.
For the test data, is it a fairly large data set, or did you have any challenges sort of version controlling large test data sets?
It's actually small. So the person asks, like, did you have any trouble versioning test data? Wouldn't it be kind of big? So what we were after was making all of our acceptance tests pass. So if we can make all of our acceptance tests pass, that was like a sort of a milestone. And so that's what we've attacked so far. There's other useful data, like, for example, all of our prod learning content that would be nice to have in that data set as well. If it were zero cost, it's not zero cost. So we have other scripts that selectively say, give me all of the prod content, for example, and that takes something more than the minutes that we would be after in terms of running this data refresh on every pipeline run. Yes, sir.
Regarding the question about the unit testing, I wanted to say that one of the alternative ways of dismissing the developers would be to try to convince the product owner that as part of the definition of done, you can say that there will be unit testing covered features. I had better luck with this one, but
Nice.
I had a question about like how do you manage databases? Like do you automate the database deployments?
So how do you handle database deployments? Is that automated? So we have pretty uniform sort of databases behind all these apps that we use. So we're mostly MySQL. So as a part of each deployment, we go ahead and we fire off a one-shot Docker container that has the app inside of it. And there is a sort of spec that says, if you write apps and you want them to be deployed to production, you also must supply a script that can migrate your database. And so like some technologies make that easier than others. But if your technology makes it hard, go figure it out yourself. And so it runs a script to make sure that it's using the newest database that would be implied by that version of the code that we're shipping. And that happens along with the deployment of the code.
So this is actually very interesting because so reorganizing a database, we make a schema change. It's not a trivial thing. You can script it all you want, but it's going to take time. So when you drive production, even using Docker, how do you manage downtime?
So how do you manage downtime is the question. So we don't have a ton of downtime. So we try to basically dance around it with engineering and writing a lot of code around it.
So you create like mirror copies, spin those up, and then flip it into network.
Or we make new data models that are mimicking existing data models. Or it really depends on the use case, but we go ahead and do do a lot of work to avoid downtime. Essentially, is the answer I think to that.
We use so many tools, right? And so many updates are happening weekly, quarterly, monthly basis. What is your philosophy or policies, and how are you managing keeping them up to date with the latest versions across your teams, across your administration, and all that?
Okay, so there's so many things flying around, so many versions, so many changes happening. How do you make sure everything is up to date with those new versions, essentially? So,
Jenkins, Docker, everything else.
So we try to keep our environments uniform, and one of the stages in the pipeline is actually, if you have a new version that just went to production, distribute it out to all environments. That's actually one of the stages. So if the pipeline is all green, it has done that. So that means none of the environments will be left behind in terms of application changes. In terms of configuration management changes, we use Chef for that, and so there's basically trying to push everything and try not to say you're done with the task until that concern has been sort of addressed. Excellent. Thank you so much for participating so well. If you have other questions, feel free to get in touch with me later. Thank you so much.